Hi there, this is gonna be the second video about the false position method for a continuous function. And I made the very first one already, so you should check it out. Anyway, it is gonna be the second example because, as I always say, the more the better. So let's start with the function. Our function is gonna be this time x cubed minus 2 equal to 0. And we are gonna start with 2 points, x1, which is gonna be equal to 0.5, and x2, which is gonna be equal to 2. So hopefully, we're gonna plug those 2 points, first x1 and then x of 2, into the function, and hopefully we're going to get a positive value and a negative value, which means that if the function is continuous, then there must be a point in which it's 0, so in which it crosses the axis and then it's 0. So let's try to find out. If I do f of 0.5 and I plug 0.5 back into our function f of x, then I get 0.5 cubed minus 2, therefore 0.125 minus 2, so negative 1.87, which is negative value. So now we expect a positive value from x of 2. So f of 2, so f of 2, if we plug 2 into this function, we get 2 to the third minus 2, so 8 minus 2 equal to 6. So we're good. We got a negative value, we have got a negative value and a positive value. Therefore, if the function is continuous, there must be a point in which you're going to cross the axis. So let's draw a little sketch here. It's going to be my x axis and the y axis. Alright, this is 0. So our points are actually 0.5, which is our x1, and 2, which is our x2. And then we have got that at 0.5 is actually the function is negative, so negative 1.87, so roughly here, negative 1.87. There we go. And at 2, the function is positive, and its value is 6. There we go. So, as you can see, there must be a point somewhere between 0.5 and 2 in which the function is actually going to cross the axis, and therefore it's going to be 0, and we are looking for this point. So, I'm going to write for the false position method, we have xr equal to x2 times f of x1 minus x1 times f of x2, everything over f of x1 minus f of x2. There we go. So basically, what this formula says is that x of r1 is going to be x2, so basically 2, times f of x1, so the value in in x1, so negative 1.87, minus x1, so 0.5, times f of x2, so 6, everything over f of x1 minus f of x2, so f of x1 negative 1.87 minus f of x2, so 6. There we go. So now we basically compute this, and negative 3.74 minus 3 over negative 7.87, and we get negative 6.74 over negative 7.87, which gives us 6 point, well, yes, that's 74 over 7.87, which is 0.85. So there we have it. 0.85 is going to be our new point. So it's going to be 0.85, like here, 0.85. And now we're going to plug the point that we have just found, so 0.85, back into our function, and we're going to see whether it's going to be still, you know, positive or negative, and so on. And according to whether it's going to be positive or negative, I'm going to go on. So for instance, if it's positive, then it must be, you know, it must be somewhere like here. Therefore, it's not going to cross the axis here, but it's going to cross the axis between 0.5 and 0.85. If it's negative, it's not going to cross the axis between 0.5 and 0.85, but it's going to cross the axis between 0.85 and 2. So we're going to go on in this direction or in this direction. So f of 0.85, well, if you plug in 0.85 into our function, we basically get 0.85 cube minus 2, which gives us 0.61 minus 2, so negative 1.38. Therefore, it's still negative. So roughly like here, 1.38. There we go. So here. Now we go on, and since it's negative, it means that it's going to cross the axis between 0.85 and 2. So we're going to use those 2 points as our new starting points. Therefore, we're going to have XR2. It's going to be, so 0.85 is going to be our X1, and 2 is still going to be our X2. So the formula says X2, so it's 2 times f of X1, so negative 1.38, minus X1, so 0.85, times f of X2, so 6. Everything over f of X1, so negative 1.38, minus f of X2, so 6, so minus 6. And if we compute this, we get negative 2.76 minus 5.1 over negative 7.38. So we got negative 7.86 over negative 7.38, which is like saying 7.86 over 7.38, which is 1.06. So our new point, in which we're going to compute the function, is going to be 1.06. So like here, 1.06. So let's just plug in 1.06 back into our function. So f of 1.06 is actually going to be equal to 1.06 cube minus 2. It's going to give us 1.20 minus 2, so negative 0.8. So it's still negative, and now we get negative 0.8. So, you know, as you can basically see, we're getting closer, and eventually we're going to get closer and closer and closer to 0. and we're gonna get a better and better approximation. So, but right now I'm gonna stop with those two, iterations, so XR1 and XR2. So our best guess is gonna be that the function is gonna be like this. And it's gonna cross the axis like somewhere between here. So there we go. This is the second example about the false position method. I'm gonna make many other one because the more the better. So stay tuned. Bye for now.